Okay, by the end of today's lesson, you should be able to derive equivalent trig expressions using right triangles in the unit circle. And you should also be able to evaluate trig expressions and angles using equivalent trig expressions. Now, I forgot to post the formula sheet that you're going to be allowed to use on the test. So I will be giving you that, and I will post it on the website, but I will also print you off a copy of it, which you will need for this lesson and for the test. So equivalent trig expressions are expressions that yield the same value for all values of the variable. And you know what an identity is because you did trig identities in degrees last year. So an identity is an equation that is true for all values of the variable for which the expression on both sides of the equation is defined. And you know trig identities, as I said, from last year. But there are other identities that you're going to learn, and one of them is called the co-function identity. So this is the derivation of the co-function identity, if you will. You won't be asked to derive it. You do have the formula sheet for the test, but it's good to understand where this is all coming from. So here we go. We've got this co-function identity. We've got this right triangle. If this is x, and this is a right triangle, pi by 2, then this angle must be pi by 2 minus x, right? Think about it in terms of 90 degrees. If this is 90 degrees and this is x, then this angle up here must be 90 minus x, okay? All right, if we attach letters to the side, so A, B, and C, then the sine of x is A over B, right? And the cos of x is C over B. And let's just keep going here. The sine of pi by 2 minus x, which is that other angle, then, if I just stuck my finger on this angle, it's going to be C over B. And the cos of pi by 2 minus x is A over B. Okay? With me so far? All right. Then we can see that the sine of x is the same as the cos of pi by 2 minus x. These are the same, right? They're equal to A over B. And we can also see that the cos of x is equivalent to the sine of pi by 2 minus x. So those are our co-function identities, they're called. If you have the sine of x, that's going to equal to cos of pi by 2 minus x. If you have the cos of x, that's going to equal the sine of pi by 2 minus x. We could do it for tan as well. So the tan of x is A over C. The cotan of x is C over A. And therefore, we can see, if we keep going with the tan of pi by 2 minus x, that's going to be C over A. And the cotan of pi by 2 minus x is A over C. So when we distill all that down, you can see then that the tan of x is equivalent to the cotan of pi by 2 minus x, and the cotan of x equals the tan of pi by 2 minus x. Again, another co-function identity, which will be on the formula sheet that I give you. I find that students have a lot of difficulty with these types of questions that I'm about to do. All I can tell you is try to follow the format the same way every time if possible to avoid confusion. The important thing in this question is that you are showing me that you're using an identity. Because remember, an identity is already a statement that we know to be true. So it's not like we're finding anything out. We know that this is true already. And so you're just showing something usually that is using something that is true. And you're not actually solving for anything or calculating anything. So let's just see where we're going to go with this. The first thing we want to do, it says, given that sine pi by 5 is equal to approximately 0.5878, use an equivalent trig expression to evaluate the following to 4 decimal places. So we want to know the cos of 3 pi by 10. Well, the cos of 3 pi by 10, 3 pi by 10 is not part of a special triangle, so we can't just evaluate it exactly. How is this related to the sine of pi by 5, right, is the question. And so what I want you to do is take this angle here, 3 pi by 10, and you're going to ask yourself, is that greater or less than pi by 2? So 3 pi by 10 is less than pi by 2. Okay? We know that because 5 pi by 10 would be pi by 2. So anything less than 5 is less than pi by 2. Okay, so then we are going to break up 3 pi by 10 into pi by 2 and another angle. So we're going to say pi by 2 minus x is going to give us 3 pi by 10. Okay, so we're going to subtract something from pi by 2 to give us 3 pi by 10. What are we subtracting? Well, x, if I move x to the other side and I move this to the other side, we get pi by 2 minus 3 pi by 10. Now it's just a matter of adding fractions. This is really 5 pi by 10 minus 3 pi by 10, which is 2 pi by 10, which is, of course, pi by 5. Okay, so we now have that x is pi by 5. So I know that pi by 2 minus pi by 5 is equal to 3 pi by 10, right? I go back to this original expression here. Pi by 2 minus x equals this. I found out what x was. It's pi by 5. So I'm putting it in here. So now I can rewrite, I'll just say rewrite cos 3 pi by 10. So I know that cos 3 pi by 10 is going to equal the cos of pi by 2 minus pi by 5. With me? So I've just rewritten that because I know that this is true up here. Now we're going to use an identity. So this is where you're going to go to your table, your formula sheet, and you're going to find an identity that has cos of pi by 2 minus x related to it. And I think you can see that the cos of pi by 2 minus x is equal to the sine of x. That's one of your identities. Okay? So then, what I now know is this is the cos of pi by 2 minus pi by 5. If I put pi by 5 in here, that's got to be equal to the sine of pi by 5. You with me? And I know that the cos of pi by 2 minus pi by 5 is 3 pi by 10. So the cos of 3 pi by 10 is equal to the sine of pi by 5. And now I've related these two. So I know that the cos of 3 pi by 10 is equal to 0.5878. I was able to use that that ratio that was given in the problem to solve for this one, not to solve for sine of pi by 5, because we already knew that the sine of pi by 5 was this ratio, but I wasn't sure what the cos of 3 pi by 10 was. But because now I know that these are equivalent, I can say that the cos of 3 pi by 10 is also equal to 0.5878. Okay, I know that's tricky, and we're going to try another one now. So just give me a second. I'm just going to clear this, and we're going to do the cos of 7 pi by 10. Okay. So I'm just going to say this is B here. So we're going to do it exactly the same way, but this time 7 pi by 10, is that greater or less than pi by 2? It's greater than pi by 2, okay? So that means that we're going to try to find an angle pi by 2 plus an x, something else, to get us to 7 pi by 10, okay? X then is going to be 7 pi by 10 minus pi by 2. So this is 5 pi by 10 when I try to get a common denominator. And this is going to be 2 pi by 10 again. And x is going to be pi by 5. So we're going to rewrite then the cos of 7 pi by 10. Well, wait, let me just actually go back here. I'm going to say pi over 2 plus pi by 5 then, our x that we discovered here is 7 pi by 10. So that's true. So that means that the cos of pi by 2 plus pi by 5, put that in brackets, is equal to the cos of 7 pi by 10. Okay, use an identity. Well, now what we're doing is we're looking at our formula sheet for ones that have pi by 2 plus an angle. And we can see that there is an identity there that says the cos. And I will be expecting you to show me the identity that you have chosen. And this is the identity that I see. The cos of pi by 2 plus x is equal to minus sine x. Okay, I needed to look for one with pi by 2 plus in it. And I found one, minus sine x. All right, so now we're going to use that identity. We're going to say the cos of pi by 2 plus pi by 5 then. If this is my x, pi by 5, that's going to equal minus the sine of pi by 5. I know what the sine of pi by 5 was. I was given that value. So the cos of pi by 2 plus pi by 5 in brackets is equal to minus 0.5878. Okay, because I have the sine of pi by 5, I'm just taking the negative of it. Okay, so if the cos of pi by 2 plus pi by 5 is equal to minus 0.5878, then so is the cos of 7 pi by 10, because these are equivalent. So the cos of 7 pi by 10 is equal to minus 0.5878 approximately. Okay, so the key things here are to rewrite this as the sum or difference using pi by 2 of that angle that you've been given here. And then you're going to use an identity to solve for that particular angle. Not solve, but find the ratio for that particular angle. Okay. Next question. Given that cosecant 2 pi by 7 is approximately equal to 1.2790, use an equivalent trig expression to determine the secant of 3 pi by 14 to 4 decimal places. Okay, so we're relating here cosecant and sec, but we're going to start with our angle here, which is 3 pi by 14. So again, 3 pi by 14, we're going to check. It is less than pi by 2, because 7 pi by 14 obviously is pi by 2. So it's going to be less than pi by 2. So we know that we're going to then say pi by 2 minus an angle is going to give us 3 pi by 14. What's that angle? X is going to equal pi by 2 minus 3 pi by 14. And x then is going to equal 7 minus 3, that's 4 pi by 14, or 2 pi by 7. Okay, so x is 2 pi by 7, so we can put it back up in here. Then we're going to say, so pi by 2 minus 2 pi by 7 is equal to 3 pi by 14. And then we would say the it's not cos, it's the secant, it's this one, of pi by 2 minus 2 pi by 7 is going to equal the secant of 3 pi by 14. Oopsie. There we go. Okay, so we haven't started using an identity yet. We've just rewritten our original question so that it is in terms of two angles. Now what I need to do is I need to go search my formula sheet for something that's going to relate pi by 2 minus an angle, sec of pi by 2 minus an angle, and cosecant. So let's see what we can see here. So I've got the secant of, let's see, secant of pi by 2 plus an angle. That's not what I want. Secant of pi by 2 minus an angle. That's going to equal cosecant x. So I can go back, see, and I can say the secant, just write out the identity of pi by 2 minus x is going to equal the cosecant of x. That's your identity. You're going to use that. Write it out, and like, don't put anything in yet. And then you're going to start substituting in. You've got x. X was 2 pi by 7 is going to equal cosecant of x. These x's are the same, so you're just going to put in 2 pi by 7. And lo and behold, you know, because you were given the cosecant of 2 pi by 7, that's going to equal 1.2790. So you're going to say the secant, you know that this is equivalent to 3 pi by 14. Well, we can keep it as pi by 2 for now, maybe. Pi by 2 minus 2 pi by 7 is going to equal 1.279. And then the secant of 3 pi by 14 is also going to equal 1.2790 approximately. Okay? So again, you almost feel like you're going a little bit in circles because you were given the answer, or were you? Sometimes it's the positive or the negative. But this is what it's expecting you to do in these questions. Okay, last question. Given that cotan 2 pi by 7 is approximately 0.7975, use equivalent expressions to evaluate the following to 4 decimal places. Tan 3 pi by 14. Alrighty. So again, we take the angle here, 3 pi by 14, and we decide, is it greater than or less than pi by 2? And we know that it's less than pi by 2. So we know we're going to take pi by 2 minus a different angle, and that's going to give us 3 pi by 14. When I rearrange, this is going to give me pi by 2 minus 3 pi by 14, and x then is going to be 7 pi by 14 minus 3 pi by 14, which is 4 pi by 14, which is 2 pi by 7. Alright, so now what I have is I have that pi by 2, pi by 2, why is it doing that? Pi by 2 minus 2 pi by 7 gives me 3 pi by 14. I'm just going to write that out. I'm going to then put it into tan. Tan of pi by 2 minus 2 pi by 7 is equal to the tan of 3 pi by 14. I also now go into my formula sheet and look for the tan of pi by 2 minus x. And I see that I have an identity, tan of pi by 2 minus x equals cotan of x. I know that I have the tan of pi by 2 minus 2 pi by 7 equals the cotan then of 2 pi by 7. So I've applied an identity here, and I know then that this is equivalent to tan of 3 pi by 14. I know that the cotan of 2 pi by 7 is approximately 0.7975, so I have evaluated the tan of 3 pi by 14 to 4 decimal places. Okay, let's try the last one. just going to have a quick peek at the formula sheet for 2 seconds. So the tan where are you? Okay, it's mine. Okay. So, I might not have that much room, but we'll try. So we've got 11 pi by 14. 11 pi by 14 is definitely greater than pi by 2. So we know that we're going to be looking for an identity with pi by 2 plus x. And that's going to equal 11 pi by 14. So x is going to equal 11 pi by 14 minus pi by 2. 11 pi by 14 minus 7 pi by 14, which is this equivalent, is 4 pi by 14, which is 2 pi by 7. So again, we have that pi by 2 plus 2 pi by 7 equals 11 pi by 14. So I know that if I take the tan of pi by 2 plus 2 pi by 7, I'm going to get the tan of 11 pi by 14. Sorry, it's messy. Okay, and so now I'm going to go to my chart and I'm going to, my formula sheet, and I'm going to choose an identity, and this should be in brackets. Sorry about that. Right here. It's so messy. Okay. So I look in my formula sheet and I see the tan of pi by 2 plus x is equal to the minus cotan of x. So make sure it's minus cotan of x there. And then I'm just going to put in my x value, which is the tan of pi by 2 plus my x value, which is 2 pi by 7, is going to equal minus the cotan of 2 pi by 7. And I know that this is the tan of 11 pi by 14. It's equivalent, this angle, and so that's going to equal negative 0.7975 because I've got the cotan here and I need to take the negative of it. Okay, sorry that's a little bit messy, but that's it. So just try to follow that formula, that format pretty well exactly, and you can't get into any trouble. All right, good night.